Hi, this is Dr. John Bergduff. In this video, we're going to look at another one of the tools that MyMathLab has for graphing functions. And there's some fairly basic ones that focus on plotting points for well-known shapes. But the ones we're going to look at today are going to enable us to graph fairly complicated polynomial functions. The technique basically will focus on plotting points, but a little bit more complicated than a straight line or something like that. Now, this tool is primarily usable in degree 3 polynomials. That means that the highest exponent on any variable is a 3, like you see right here. And I'm going to assume as you look at this video that you have already learned about the rational zero theorem, because as you can see in the instructions here, it says that they would first like you to factor the expression. And you can do that with the rational zeros theorem and synthetic division. So I have already done that over here, and it can be shown with not too much work that this function can be written in factored form as the quantity x minus 1 times the quantity x plus 3 times the quantity x plus 7. Now, how does that help us graph? Well, for one thing, once a polynomial function is written in factored form, the x-intercepts are found by simply setting each one of the factors equal to 0. So I can easily tell what the x-intercepts of this graph are by setting each factor equal to 0. They would be 1, -3, and -7. And those would represent points that I could plot on a graph very, very easily. We also know that in graphing a polynomial function, it's nice to find out what the y-intercept is as well. The y-intercept is found by calculating f of 0. In other words, what do you get when you plug in 0 for x? And I think it's pretty easy to see as you look at this function that the first, second, and third terms would all become 0. So f of 0 is -21. Now, this is all very fortunate because this particular graphing tool for graphing polynomials of degree 3 requires you to know 4 points on the graph. We've got 3 x-intercepts and we've got a y-intercept. So that's going to be good enough. Let's see how this works. So click on this icon here that says click to enlarge the graph. And you'll see that there's many graphing tools that many of which you may have seen elsewhere. Let me kind of rearrange my screen a little bit so you can see everything. One thing you'll see straight lines and you'll see V shapes and parabolas and circles and so forth. This is the tool for graphing a cubic polynomial. Notice it's called a 4-point cubic tool. And this is worked by simply plotting the points. Now, you'd like to plot these points either from left to right or right to left. If you kind of skip all over, this tool doesn't like it very much. So I'm going to start on the left end. And as I look at the left end and I look at my x-intercepts, I notice that there's one at -7. So I'm going to click a point at -7 on the x-axis. There's also one at -3. That's right here. And so far, this doesn't look terribly exciting. But when I plot the y-intercept, that's going to really help. So I'm going to plot a third point. The next point I'd come to would be the y-intercept. And that would be, that's 18, 20, 21 is right there. And then finally, there's one more point, and you can see how this just bends directly to the shape at an x-intercept of 1. And it's now happy because you have graphed 4 points. Click Save, check the answer, and we got it right. So very nice tool for graphing something, but it has to be a degree 3 polynomial. Let's look at one other. All right, notice that this function is already in factored form. So finding the x-intercepts will be no problem at all. Let me just make a little bit more space on my scratch paper over here. The x-intercepts this time. Set each factor equal to 0. If I set 2x equal to 0, I will get 0. Set x minus 2 equal to 0, and I'll get 2. And set x plus 1 equal to 0, and I get -1. Now the Y-intercept is found by plugging in 0 for x, but if you notice that carefully, plugging in 0 for x is going to give you 0. So the x-intercept is 0 and the y-intercept is 0. Nothing wrong with that, but the problem is, because that's actually just 1 point, we only have 3 points. So when that happens with this tool, what you have to do is you do have to calculate one more point using an x value that you haven't used so far. So pick one that's not too hard to do. I'm going to pick 1. F of 1 would be equal to 2 times 1 times the quantity 1 minus 2 times the quantity 1 plus 1. Let's see what that would be. That would equal 2 times negative 1 times 2, and that would give you a negative 4 if I'm doing that correctly. So that gives me one more point. That's one more point. The point exactly, just so we're clear about this, is 1, negative 4. Click to enlarge, and let's plot these points. Again, you want to be careful to plot them more or less left to right or right to left. So this is going to be a 4-point cubic tool, so I click that tool. The first point I see if I read left to right is negative 1 as an x-intercept. And then I have 0 as both an x-intercept and a y-intercept. I have a point at 1, negative 4, and oh, this has to be done so carefully. 1, negative 4, looks like it's right there. And then finally, one more x-intercept at 2. And if you use different points, that's fine. It will recognize that as well. Save that. Check the answer. And actually, the hardest part is that last part of making sure you've got the point exactly right. So this gives you a way to graph degree 3 polynomials at least using a tool on MyMathLab. So these questions don't have to be multiple choice. And I hope that is very, very helpful.